Hello, here we are live streaming an answer to a great question. A classmate of yours asked, can you walk me through chi-square methods calculations with some technology? They normally use Desmos. Uh, I don't know how to do it using Desmos, but I sure do know how using GeoGebra. Let's walk through that together. So I'm going to uh, share share my screen with you and we can walk through it. Here we go. So here we are home at our class. Uh, Anytime we want to do some calculations, we need something to work on. I've got an idea. Let's go into the content and I'm going to head into our third module, multiple proportions. And hey, I've already landed there because I was checking this out earlier. And you can see here, there's the goodness of fit methods. I'll post this video probably in that little zone right there, even though it's not the best video. But if I scroll down, oh, sorry. So here we are in goodness of fit. There's a little stuff to read here. I just noticed today this online textbook link is bad. I'll fix that today. But we do have these slides that have some good ideas in them, and they've got a good example we can use to do this work. So here we go. The way the reader works, I got to scroll down to see the stuff. Hey, friend. There we go. So these are the slides that come with the textbook. There's some interesting examples on these. If you haven't been checking them out, you might get something out of it. There's some interesting stuff to see and learn. The first example about dice is not good for our purposes because all the numbers are like well over 50,000 and they're kind of hard to read and say. Let's look at the second example in these slides to talk about how to calculate the p-value for a goodness of fit test. And in that process, we're even going to talk about the general idea. So the second example here is about the 2009 Iranian election. And it says here, there was lots of talk of election fraud in the 2009 Iranian election. Hey, I can think of some more recent elections where there was lots of talk about election fraud, whether or not it occurred. So let's not worry too much about the political and historical implications here because I don't know much about 2009 Iran politics. We'll compare some data from a poll conducted before the election. That's the observed number of voters polled, who out of 500 polled voters, a different number of people said they'd vote for Ahmadinejad, who did win the election. The challenger candidate Mousavi, or minor candidates who didn't really have much of a chance to win, as you can see by those poll numbers. And then you can see the reported number of votes from the election, so from the Iranian election counting group, reported the proportions that way. So for goodness of fit, the goal is to find out if the observed counts from the poll match up to what you'd expect if there was no election fraud, right? They should match up fairly well. Okay. But remember, I'll get to the calculations. I just want to set it all up just in case this helps anybody else out. So hypotheses wise, anytime you're talking about goodness of fit testing, the null hypothesis is the observations we have match our expectations. So in this case, our observed counts from the poll should follow the same distribution as those reported votes. Our counts are counts, and the reporting is in percentages. We'll have to make an adjustment there to get the test done. We'll get to that in a minute. And alternatively, the goodness of fit alternative is not such a good fit. So in this case, the observed counts from the poll do not follow that distribution of the reported votes. So that would indicate there was possibly some funniness happening somewhere in the process. Again, too complicated for me to understand as someone who does not know their recent Iranian history well at all. Okay, here's how and let me, for our eyes, I'm just going to get rid of, well, we talk about this. I'm going to erase for my eyes so I don't get distracted. All this stuff at the bottom, that's like how you do the calculations, the formulas and stuff that we're not going to worry about. But to do these calculations using technology, the stuff we see up at the top here is crucially important. On the previous slide, we did have this information. Who's running in the election, Ahmadinejad, Mousavi, and the minor candidates. We have the observed counts in that first column and the reported percentages of them in the second column. Now, when you do goodness of fit calculations, whether you're doing them by hand with formulas or using technology, you're going to have observed numbers, and you also need expected numbers, not percentages. So whenever you have percentages in one of these problem settings, there's going to be some transitioning from percentages to counts. And the way you do that is you just look at the total number of observations you have. If you have these percentages that have to add to 100, and to get the expected numbers, look at that. Take our 504 total observed and multiply it by each percentage to get the expected number of votes in the poll. And they've rounded them off to the nearest whole voter. You can hold on to decimals there. It's not going to affect the technology, though, of course, it doesn't really make sense to write down numbers with decimal values. I hope that's clear. But so what's crucially important for us, the columns that we're really going to need to use here are really, for our calculations, this one, observed counts, and these ones, these expected counts, right? I'm trying to make an L-shaped box there. Everything else there is important because you've got to get from percentages to counts for the expectations. Okay, now at the bottom of this slide, it showed how to use formulas to calculate these, to calculate the p-value to check against the hypotheses. Let's erase all this stuff, and then let me give you a couple of notes as we go in typing. I'm going to go to GeoGebra, and the web page is called Hey Friend. And I'll try to keep some notes on this screen for you that we can then, you'll see. Give me a new tab. I'm going to go to www.geogebra.org/classic. Okay, that's the homepage of this website that is real useful for doing lots of statistical calculations. And when we arrive here, I'm going to start a little list. Just, there's the website, geogebra.org/classic. And here we're going to go to the probability. So I'm going to say this is sort of step 1. Make this nice and wide so we can read it. Here's step 2, probability. So you can see that little normal distribution on the screen in that GeoGebra Classic menu over there. That's our probability calculator. And we're going to head to that to do our work. So here I go, selecting probability. Come on, computer. Great. We land at this page, and you can see, let me actually move my little notes over this direction. You'll see why. Up at the top of this page, we have two options here, distribution or statistics. When you want to do a hypothesis test or construct a confidence interval using GeoGebra, you want to go to the statistics tab here at the top of the screen. So next step, statistics tab. And in my little notes, let's put that down. Probability calculator is what that's officially called. Statistics. Let's tab. Maybe I'll just go like this. Yeah. And then the next thing. Oh, sorry, there's a little bit of screen stuff. I've got to make some adjustment here. Okay, the next thing is when you've landed at our statistics tab, now we've got lots of options for what kind of work we want to do in this menu at the top. Z-test of a mean. Well, if you like GeoGebra, you can come back here when we do hypothesis tests about one population mean. That's the option that's preset. But this menu opens up, and in here, you set it to the test you want to do. In our case, that's going to be a goodness of fit test. It's the second to last one in the menu. So in my little notes over here, a goodness of fit test menu. And I think that's all the notes I've got to add to my little list, except maybe one more little note would say, select rows first, because when we're setting this up, if you start typing values in and you run out of rows, then you reset the rows to how many you need. Like we do have in the data set here, coincidentally, 3 rows. So when we collect our numbers and enter them into GeoGebra, we're set. We have 3 groups. But if there were 4 or 5 or any number higher, you'd want to reset this rows number to as many as you need. And I don't think we're going to go higher than, I don't know, 5 or 6 ever in this class. Probably not even that high. You'll certainly never see anything above 8, not above 8 here. And then you can just set it up by just getting it going. Ahmadinejad, I don't know how to spell that. So, and you don't need to label these, but I'm going to, just so that we can sort of refer to them. So I'm just going to go AHM for Ahmadinejad for short. Just the first 3 letters of his name. Musavi, I'll just put MOU. Oh, I'm not going to mess with any of those commands. And, I'll put off for other to just maintain my style there. And then I want to enter the observed counts and the expected counts, the same values that I boxed earlier in the notes. So select rows first, enter counts. Beep, beep. Not percentages, right? Counts. So here we go. We have 338, 136, and 30 for observations. 338, 136, 30. Okay, and 504. Isn't that nice how it automatically totals them up? So when I go look back at my notes, I get a little double check that it's 504. So I'm fairly confident I didn't make a mistake there. For the expected numbers, we already have them calculated here: 319, 172, 13. 319, 172, 13. Okay, and again, they add up to a 54. If you are rounding off those expected counts in the process of doing this, that could be one lower or one higher due to rounding. So that shouldn't be surprising, but if they're right on, you're doing this perfectly. And the second we've entered all those values here, we can see the degrees of freedom is going to be 2. That's because we have 3 voting options, Ahmadinejad, Musavi, or the other candidates. So subtract 1 to get 2 degrees of freedom. We can see the chi-square statistic. There's that Greek letter chi squared is almost 31, which, as you get more familiar with this method, you'll recognize immediately as a huge statistic. And that brings back a p-value of 0, calculated right there at the bottom of this page. Let's peek back at the slides too to see how to check our work. So almost 31 for the chi-squared statistic, 0 for the p-value. Oh, pardon me, let me keep those notes just so we don't lose them. Just set them over here, kind of. It looks a little messy, but I'm not a graphic designer. There it is, applying the formula, which is a little more complicated. If anyone ever wants to talk about how that works, let me know. But they end up with the chi-squared statistic of 30.89, which is up to rounding exactly what we got back in GeoGebra. And then if you were not doing this with technology, the next step would be to, oh, oops, what's going on, computer? There we go. Oh, they don't have it on this slide, but let's look at it in GeoGebra just to have a picture of this p-value. The chi-squared statistic 30.89, let's round it off just by truncating it. That gets plugged into the distribution of the chi-squared probability distribution. So heading back to the distribution tab at the top of our screen, here you've got all sorts of options for calculating probabilities using probability models. As you open it up in the distribution tab, you'll see the menu there shows normal, the normal distribution on the screen. And right there, third option is chi-squared. The only option you need to turn on to get the correct shape of the distribution is the degrees of freedom DF with 3 groups here. That's 2. You'll always see well, the lower the degrees of freedom gets, the more skewed the distribution looks. The higher it gets, the more it starts to look more and more like a normal curve. You always want to look at the upper tail in this distribution to get the area under it, like the likelihood of observing the differences we see between observations and expectations if our assumption that they match is true. So that's always going to be the right-handed tail. Here, if I put in that 30.89, well, if your device screen is big enough, you should have already been able to see the numbering on the screen is up to 7.5 here. So to get to 30.89, we'd have to go way, way off the screen in that direction. That curve will get way, way down close to there. So there's not really any area out there. Our p-value is 0. So that's our p-value. The picture, it's not visible on that curve, but at least you kind of have a sense of where it is. More importantly, there's your goodness of fit test. Remember, that lives in the menu of the statistics tab of the probability calculator of www.geogebra.org/classic. And if anyone has any follow-up questions, reach out anytime. I hope that was helpful. And I'll make one more of these little videos to show you how to do tests of independence and homogeneity. That's a different thing. So we'll look at that. All right. Here goes the end of the live stream. Where's the controls?